Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who drifts into sleep more easily when your mind is wandering among quiet stars, letting soft ideas replace the noise that lingers from daylight hours. For now, there is nothing you need to solve or decide. Let your breath settle, your shoulders loosen, and your thoughts become light and unhurried. Because tonight, we're not simply closing our eyes. We're traveling through the gentle mysteries of wormholes, those imagined doorways in the fabric of space-time. From the earliest whispers of cosmic geometry to the dream of stepping through one sky and emerging beneath another, we'll explore 100 soothing facts that invite both rest and wonder. And if these sleepy journeys help you relax, consider liking and subscribing. It helps other late-night travelers find their way into this peaceful corner of the universe. Now, let your eyes grow heavy. Let the world around you fade into quiet. And together, let's begin. Fact 1. The fabric that can fold. Long before anyone imagined portals or shortcuts, physicists discovered that space and time are not rigid things. They behave more like a soft, flexible cloth stretched across the cosmos. When something with mass rests upon this cloth, it sinks gently, creating a curve. And where there is a curve, there is gravity, a quiet pull inviting objects to drift toward the dip. This idea, simple yet profound, is the foundation of wormholes. If the fabric can bend, perhaps it can fold. If it can fold, perhaps two distant points could touch, like corners of a blanket brought together in the dark. In this soft, curved universe, wormholes become not just sci-fi imagination, but mathematical possibilities. Quiet folds waiting to be explored. And from this gentle fabric, our journey begins, toward the next subtle bend in space-time. Fact 2. Gentle curves of gravity. When you think of gravity, you might imagine something strong or forceful. But in the language of relativity, gravity is simply the shape of space-time. Stars and planets rest upon this fabric, creating smooth valleys. Light, dust, and passing comets follow these curves naturally, as if drifting along invisible riverbeds. These curves are essential to understanding wormholes. For just as gravity can bend space, it can also twist, stretch, and, in theory, form tunnels that link faraway regions. Not through force, but through geometry, through shape. Imagine walking across a landscape of soft hills and dips. The ground gently guides each step, suggesting a path without pushing or pulling. Gravity works the same way, nudging everything along the curves it creates. When those curves become extreme, they hint at something deeper, the first whisper that tunnels might form. And so, gravity's quiet artistry leads us to the idea of a cosmic shortcut. Fact 3. The idea of a shortcut. Once scientists realized that space could bend, an intriguing question floated to the surface. If two distant stars sit on a curved sheet, could the sheet be folded so the stars nearly touch? This is the essence of a wormhole. Not a violent tear, but a gentle bridge. A fold that brings what was far away into peaceful proximity. Instead of traveling the long arc across the cosmic landscape, one could step through the fold itself. The mathematics suggested it. The imagination embraced it. And from that meeting, the first true concept of a wormhole took shape. A quiet passage hidden within the fabric of reality. Beyond this idea, something even more mysterious awaits. A doorway formed entirely by equations. Fact 4. From mathematics to mystery. When Einstein first wrote down his elegant equations of general relativity, he wasn't trying to invent cosmic tunnels. Yet hidden inside those symbols, quiet, precise, and balanced, was the possibility of paths that curved so completely they could loop back into themselves. Early physicists noticed that the equations allowed unusual shapes, bridges, folds, even tunnels that linked distant regions of space-time. These weren't objects built from matter, but structures made purely of geometry. It was as if the universe, through its mathematics, whispered, "There are more ways to travel than the straight path ahead." This realization transformed wormholes from fantasy into a real, if fragile, scientific idea. A reminder that the deepest mysteries begin with simple lines of ink on paper. And from those equations, a far stranger bridge would soon emerge. Fact 5. The Einstein-Rosen Bridge. In 1935, Einstein and his colleague Nathan Rosen studied a solution to relativity that resembled a tunnel between two distant points. They didn't call it a wormhole. That name would arrive later. But they described something astonishing: a mathematical bridge linking two separate universes, like two sheets connected by a narrow throat. This structure was perfectly symmetrical and beautifully balanced, a kind of mirror passageway formed by the intense curvature near a black hole. But it had a limitation, a quiet, disappointing flaw. The bridge pinched closed too quickly for anything to cross. It flickered into existence as a possibility, then vanished as a doorway. Still, the concept showed that nature could make tunnels, even if they were fleeting. And that simple insight kept the idea alive in the minds of dreamers and physicists alike. Where one bridge closed, another question opened. Fact 6. A door that closes too quickly. The early theoretical wormholes were like shimmering bubbles on the surface of a still pond, delicate, momentary, and gone before they could be touched. Gravity tried to hold the tunnel open, but the forces around it collapsed the passage almost instantly. Anything approaching the throat, even light, would arrive only to find the doorway sealed shut, as though the universe had second thoughts about allowing shortcuts. This fragile nature taught physicists something important. Wormholes might exist, but they are not naturally stable. They need support, balance, and a kind of pressure that ordinary matter cannot provide. Yet even in their collapse, these early models offered a promise. If a door can close, perhaps one could be opened, and kept open, gently, with the right ingredients. And so the search began for what could hold a wormhole steady in the dark. Fact 7. The dream of traversability. As physicists pondered those collapsing tunnels, a gentle, hopeful thought began to surface. What if a wormhole didn't have to close? Instead of a fleeting bridge that flickers into non-existence, perhaps the universe could host a stable, open passage, one wide enough and calm enough for light, signals, or even travelers to pass through. This idea became known as the traversable wormhole, a doorway you could cross without being crushed or trapped. It wasn't magic, just geometry behaving in a new, unexpected way. Physics didn't forbid it, but it didn't make it easy either. Still, the dream persisted. A tunnel softened by the right ingredients, supported by delicate forces, quietly waiting between two distant skies. And so, curiosity turned to the question of what could keep such a passage open. Fact 8. Exotic matter, gentle pressure. To hold a wormhole steady, the universe would need something rare, something stranger than any matter we can touch. Physicists call it exotic matter, not because it is fantastical, but because it behaves the opposite of what we expect. instead of adding pressure, it creates a gentle negative pressure. Instead of pulling in, it softly pushes outward. This peculiar effect could counteract the natural collapse of a wormhole, like a quiet hand holding open a fragile doorway. Exotic matter isn't the same as antimatter. It's a deeper, more unusual concept, born from quantum fields and the way they sometimes dip below zero energy. We haven't captured this substance or bottled it, but hints of negative energy appear in the strange, soft behaviors of the quantum world. And those hints give wormholes a whisper of possibility. With this unusual support, the tunnel's shape begins to take form. Fact 9. The shape of a portal. When scientists describe a wormhole, they often speak of mouths and a throat, borrowing gentle language to match a gentle structure. Imagine two round openings floating in space, shimmering distortions where starlight bends and curves. Each mouth leads to a narrow tunnel, the throat, stretching across a region where geometry behaves like a slow dream. The throat doesn't feel like a tube you walk through. It's more like a region where distances become soft, where the space between points relaxes and folds into smooth patterns. This simple shape, two spheres connected by a curved passage, is what makes a wormhole both elegant and mysterious. It's a doorway, created not by force, but by the way the universe chooses to bend. And just beyond that curve lies a remarkable idea, a tunnel that could shorten even the longest journey. Fact 10. A tunnel through curvature. When we imagine a wormhole, it's tempting to picture a tunnel carved through rock or carved out of space. But really, a wormhole is nothing more than curvature arranged in a special way. It doesn't break the rules of light or outrun the speed limit of the universe. Instead, it shortens the distance by bending the space in between. Think of it like folding a long ribbon so that two distant points come to rest beside one another. The traveler doesn't move faster than light. The path itself simply becomes smaller. This is the quiet magic of wormholes. Not speed, but geometry. If the universe allows such shortcuts, they would be gentle invitations to cross otherwise impossible distances, slipping through a curved whisper of space-time. Beyond this idea lies a deeper question. What exactly is the universe made of? Fact 11. The universe as a weave. To understand wormholes, it helps to picture the universe not as an empty expanse, but as a woven tapestry of space and time. Threads interlaced in 4 dimensions. Every location, every moment, every object rests upon this delicate weave. When mass appears, it presses into the fabric, and waves of gravity ripple outward like soft vibrations. This tapestry isn't static. It stretches with cosmic expansion, vibrates with gravitational waves, and subtly shifts as galaxies drift like lanterns on a vast pond. Wormholes, if they exist, would simply be rare places where the weave folds inward, forming a tiny tunnel between two distant patches of cloth. Seeing the cosmos as a living fabric makes wormholes feel less like miracles and more like natural quirks of a flexible universe. And once we see the universe as a weave, we can imagine the landscape it shapes. Fact 12. Smooth planes and twisted paths. Space-time is usually calm, a nearly flat plane where objects move smoothly and light travels in straight lines. But immense gravity can twist this plane into deep valleys, spiraling slopes, and gentle ridges. Near stars, the fabric dips. Near black holes, it stretches into dramatic funnels. And in the most extreme possibilities, it curls into tunnels connecting faraway regions. These contortions aren't abrupt or violent. Instead, they are soft changes in the shape of reality. like warm air lifting a curtain or a breeze shifting tall grass. Wormholes would arise from such twists, formed not by breaking space-time, but by guiding it into uncommon patterns. To understand these shapes is to glimpse the quiet artistry of gravity itself. And from these twisted paths emerges the idea of hidden dimensions waiting just beyond our perception. Fact 13. Where dimensions meet. In our everyday experience, the world feels comfortably three-dimensional. We move up and down, left and right, forward and back. But physics quietly suggests that beneath this familiar space, additional dimensions may be curled up, hidden like delicate threads woven tightly into the cosmic fabric. Wormholes often appear in theories that include these unseen dimensions. They may rely on geometry that slips through directions we cannot point to, stretching into spaces that are folded so small we never feel them. In this way, a wormhole is not a violation of nature, but an exploration of its deeper layers, a gentle reminder that reality may be far richer than our senses reveal. Where dimensions meet, doorways sometimes arise. And in that hidden meeting place, travel feels very different from what we know. Fact 14. A passage without motion. Traveling through a wormhole wouldn't feel like speeding through a tunnel or racing across a void. Instead, it would feel strangely still. As you cross the threshold, space itself would move around you, guiding you like a leaf drifting along a calm current. Inside a wormhole, motion loses its usual meaning. You might feel weightless, suspended between one region of the universe and another. The tunnel would not rush by. It would simply be surrounding you with a quiet, otherworldly geometry. Some theorists describe wormhole travel not as moving forward, but as sliding along a curve in space-time, the way a bead follows the shape of a string. Your journey would be shaped by the space around you rather than by your own speed. It is a passage carried by the fabric itself, slow and serene. And in this drifting stillness, even light behaves in curious ways. Fact 15. Light's quiet companion. Light is usually the universe's fastest traveler, racing across the cosmos in perfect straight lines unless gravity bends its path. Near a wormhole, however, these lines begin to soften. Light curves gently around the mouth, stretching into luminous arcs and shimmering halos. This bending is not chaotic or harsh. It's graceful, like the way moonlight ripples across water. The wormhole's gravity guides every photon, drawing them into delicate patterns that reveal the tunnel's presence long before anything crosses it. If you approached a wormhole, you might see stars duplicated, their reflections appearing on the edges of the mouth. The sky would seem to fold inward, as though offering a glimpse of another distant place. And from this dance of light comes the first true sign of the doorway ahead. Beyond those glowing arcs, the wormhole's very shape begins to call. Fact 16. A tale of two mouths. Every wormhole begins with two openings, two gentle distortions in space-time that mirror each other like calm pools on opposite sides of a quiet forest. These openings are called mouths, and each one sits anchored in its own region of the universe. If you stood near one, you might not see a clear tunnel or corridor. Instead, you'd witness a strange window, a circular halo where the distant sky bends inward, offering a view of someplace far away. These mouths aren't doors in the solid sense. They're more like shimmering frames, where space folds inward and gathers into a shared connection. Through one mouth lies the other, waiting patiently across unimaginable distances. And between these two openings stretches the throat, the silent heart of a wormhole's passage. Fact 17. Gravity's soft invitation. As you approach a wormhole's mouth, you wouldn't feel a sudden pull. Gravity would welcome you gently, like an invisible breeze encouraging you forward. The curve of space-time guides objects toward the throat, not with force, but with suggestion, nudging them along natural lines of motion. Anything drifting nearby, dust, stray atoms, even a quiet ray of light, follows these curves with calm inevitability. They spiral slowly, drawn toward the opening as though responding to a soft invitation. The effect is subtle, yet unmistakable. The geometry beckons, whispering that the shortest path lies inward. This doesn't mean a wormhole is hungry or dangerous. It simply means its shape organizes the space around it, encouraging motion toward the passage. And once inside, time itself begins to behave in unusual, delicate ways. Fact 18. Timeless moments. Within time inside a wormhole doesn't flow the way it does in open space. Instead, it can stretch or compress depending on the tunnel's geometry. A traveler might feel moments slipping by slowly, each breath unhurried, while clocks outside tick at their usual pace. Or time might seem to glide faster, carrying the traveler through in what feels like a blink. This doesn't break the rules of physics. It simply reflects how gravity shapes time. Inside a wormhole, the curvature is extreme yet gentle, producing pockets of altered tempo. It's like drifting through a quiet dream, where minutes and hours lose their sharp edges. To the traveler, the experience might feel timeless, suspended between two skies, and beyond that suspended moment lies a reassuring truth. This passage is no trap. Fact 19. Horizons without danger. Unlike black holes, wormholes don't require event horizons, those one-way boundaries where nothing can escape. A traversable wormhole is open on both sides, allowing light, particles, and even travelers to move freely through its passage. There is no point of no return, no invisible line beyond which escape becomes impossible. Instead, the space around a wormhole is transparent and gentle, shaped by curvature rather than collapse. You could shine a light through one mouth and watch it appear at the other, unhindered by the kinds of traps that define black holes. This freedom makes wormholes feel less like cosmic hazards and more like delicate bridges, suspended peacefully within the universe. And from this calm distinction emerges a deeper understanding of what these portals truly are. Not traps, but connections. Fact 20. A bridge, not a trap. A wormhole doesn't pull everything inward the way a black hole does. It doesn't devour or imprison. Instead, it acts like a graceful connection between two regions of space-time, a tunnel that simply links one place to another. A traveler entering its mouth isn't doomed to fall endlessly. They are guided through a continuous curve, emerging somewhere new and untouched. This difference is subtle yet powerful. Black holes are destinations, gravitational wells that end in singularity. Wormholes, by contrast, are passages, allowing motion without destruction. Where one represents collapse, the other represents connection. In this way, wormholes embody a softer side of the universe's geometry, showing that gravity can create doorways as easily as it creates traps. And as we imagine these bridges, we drift naturally toward the question of their origins, how such remarkable tunnels might have formed. Fact 21. Born in the universe's first breath. Some theories suggest that wormholes may have formed in the very beginning, in the earliest fractions of a second after the Big Bang. During this brief moment, space-time expanded at astonishing speed, stretching and swirling like a warm mist blown into sudden motion. Amid this turbulence, tiny folds and tunnels could have emerged, created by the chaotic fluctuations of newborn geometry. Most of these primordial wormholes would have been microscopic, flickering open and shut like sparks in the dark. But a few, if conditions allowed, might have stabilized long enough to grow or persist. These ancient structures, if they survived, would now drift silently between the stars, relics of the universe's first breath. And from these tiny beginnings rises the idea of wormholes woven into the very fabric of quantum reality. Fact 22. Tiny tunnels in quantum foam. At the smallest scales imaginable, space-time is not smooth or quiet. Instead, it flickers with restless energy, a turbulent sea called quantum foam. In this microscopic realm, distances blur, time wavers, and the fabric of reality ripples like the surface of a shimmering pond. Some physicists believe that within this foam, minuscule wormholes form and dissolve constantly. These tunnels are unimaginably small, far tinier than atoms, opening for brief instants before collapsing back into the vibrating vacuum. They are not portals for travel, but natural features of a universe that never truly sits still. These tiny tunnels remind us that even emptiness is alive with motion, possibility, and hidden complexity. And from these quantum ripples emerges the idea of universes that might brush against one another. Fact 23. Bubble universes and hidden links. Certain theories describe the cosmos not as a single, isolated universe, but as a vast multiverse, filled with countless bubble universes, expanding like foam on a cosmic sea. Each bubble holds its own laws, its own stars, its own unfolding story. In such a picture, wormholes could act as bridges between these bubbles, slender threads connecting regions that would otherwise remain forever apart. These connections might appear as subtle wrinkles in the fabric, where one universe lightly touches another, creating the faint possibility of passage. Though purely theoretical, the idea paints a gentle, expansive view of reality, that our universe may be one of many, drifting among others, like lanterns floating on a calm, endless lake. And if such tunnels exist, some might grow larger under just the right conditions. Fact 24. Energy, pressure, and possibility. A tiny wormhole formed in the early universe would normally collapse instantly, its throat squeezing shut before anything could pass through. But certain pressures, unusual, delicate, and rooted in quantum behavior, might stretch a microscopic tunnel into something larger. A burst of exotic energy, or a region where space-time briefly expands, could widen the throat enough for the tunnel to stabilize. This doesn't mean wormholes grow like living things. It simply means that geometry can evolve when the surrounding space shifts. With gentle pressure, a fragile tunnel might become a passage just wide enough for light, information, or even a hypothetical traveler. Such possibilities remind us that the line between small and vast is softer than it seems. And from this stretching of tunnels arrives the strange concept of negative energy itself. Fact 25. The power of negative energy. To keep a wormhole open, the universe would need something softer and stranger than ordinary matter. This is where negative energy comes in, a subtle feature of quantum physics where the energy of empty space briefly dips below zero. It isn't mystical or dangerous. It's simply unusual, like a quiet sigh woven into the fabric of reality. The Casimir effect offers a glimpse of this phenomenon. When two metal plates sit extremely close together, the quantum fields between them behave differently than those outside, creating a tiny pressure that gently nudges the plates inward. This small effect reveals that negative energy isn't impossible. It's part of nature's whispering complexity. If such energy could be gathered, even in small amounts, it might hold a wormhole's throat open just long enough for passage. And with this foundation, cosmic history takes us back to a moment of immense transformation. Fact 26. Inflation's vast distances. In the first instance after the Big Bang, the universe underwent a phase of rapid expansion called inflation. During this time, space didn't simply stretch. It ballooned, growing faster than the speed of light, carrying tiny quantum fluctuations with it. Small ripples, once confined to microscopic scales, were pulled outward into vast structures that later seeded galaxies. If wormholes existed in this early chaos, inflation might have stretched them as well. A tunnel no larger than an atom could have been drawn out to astronomical size, carried across light years by the expanding fabric. Most would have collapsed again, but a rare few might have survived, stabilized by the very forces that shape the cosmos. Thus, inflation becomes not just a story of expansion, but of possibility. A moment when the universe briefly reshaped even its most delicate structures. And in the aftermath of this era, wormholes may have drifted into quiet sleep. Fact 27. Ancient tunnels, now asleep. If primordial wormholes were once stretched wide by the early universe, many may now lie dormant, collapsed into tiny knots hidden within the fabric of space-time. These ancient tunnels wouldn't glow or spin or draw in matter like black holes. Instead, they would linger quietly, indistinguishable from the surrounding vacuum, waiting in silence between the stars. Some theories suggest that under the right conditions, perhaps near intense gravitational fields or swirling quantum fluctuations, one of these dormant passages could briefly stir, opening for an instant before fading again. Not long enough for travel, but long enough to remind us that the universe may still hold remnants of its earliest architecture. These silent relics lead naturally to the idea that other cosmic structures could help anchor wormholes in place, and so we drift toward the concept of cosmic strings. Fact 28. Cosmic strings and loops. Among the more exotic ideas in theoretical physics is the possibility of cosmic strings, infinitesimally thin, incredibly dense filaments of energy formed in the earliest moments after the Big Bang. These strings, if they exist, would stretch across space like taut threads, curving and looping under their own immense gravity. Some researchers suggest that the intense pull of a cosmic string could help stabilize a wormhole, acting like an anchor that holds the tunnel open. If two strings passed close together or looped around one another, their combined tension might create the conditions needed for a throat to form and persist. Though hypothetical, cosmic strings offer a beautiful mental picture. Long, shimmering threads woven through the universe, occasionally knotting into portals that link distant regions of space-time. And from these anchored possibilities, we drift into the idea of wormholes that connect not just places, but eras. Fact 29. Primordial bridges. Between eras, wormholes need not link only distant corners of space. In theory, they could also connect different moments in time. In the early universe, when space-time was still fluid and rapidly changing, tunnels might have formed between regions separated by fractions of a second. Over billions of years, those regions would drift far apart, not only in distance, but in cosmic age. If even one such tunnel survived, stepping through it could mean emerging into a younger or older phase of the universe's history. Not time travel in the fantastical sense, but a gentle bridge between eras shaped by the motion of cosmic expansion. Though deeply speculative, this idea reminds us that space and time are intertwined threads, and wormholes may tug softly at their weave in ways we barely understand. And from these ancient bridges comes the thought that some wormholes may be nothing more than happy accidents. Fact 30. Accidents of creation. The early universe was a place of tremendous energy, rapid change, and wild experimentation. Fields surged, particles collided, and space-time twisted in countless ways. In such a chaotic environment, wormholes may have formed not because the universe intended them, but because they were natural byproducts of turbulence. Brief, spontaneous wrinkles appearing in a cosmic storm. Most would have collapsed immediately. A few might have lingered. Their existence would not require purpose or precision, only the random creativity of a universe shaping itself. These accidental wormholes would be as natural as waves on the ocean or patterns in drifting sand, a quiet reminder that complexity often arises without intention. And from these chance creations emerges a new focus: what it would be like to encounter a wormhole up close. Fact 31. What you'd see approaching one. If you drifted slowly toward a wormhole, you wouldn't notice a sharp edge or a dramatic boundary. Instead, the sky would begin to shift softly. Stars behind the wormhole would stretch into curved streaks, bending around the mouth like reflections in a polished sphere. The colors might shimmer subtly, not flashing or flickering, but blending into delicate halos, an optical whisper revealing the tunnel's presence. The wormhole itself wouldn't glow with heat or radiate danger. It would appear as a dark, rounded opening where space gently folds inward, outlined by a luminous ring of distorted starlight. The closer you came, the clearer this ring would become, as though the universe were framing an unseen doorway just for you. Approaching it would feel like gliding toward a peaceful mirage, one that promises not illusion, but connection. And as you neared the mouth, another delicate effect would appear: the halo of lensed light. Fact 32. The halo of lensed light. Around the edge of a wormhole, light curves so gracefully that it forms a perfect circle, a Einstein ring shaped not by mass alone, but by the tunnel's unique geometry. This halo isn't bright or overwhelming. It's soft, like moonlight diffused through morning mist. Stars behind the wormhole appear doubled or stretched into thin arcs, creating patterns that shimmer quietly in the darkness. This ring tells astronomers something important. A wormhole can act like a lens, bending light in ways that reveal its presence even from afar. But to a traveler, it would be something gentler, a sign that space is turning inward, preparing a passage to somewhere distant. Standing before such a halo would feel like standing beside the edge of a calm pond, watching ripples reflect the world in unexpected shapes. And beyond that glowing ring lies the moment of entry, gentle, silent, and strangely serene. Fact 33. Falling without fear. Entering a wormhole wouldn't feel like tumbling into danger or being pulled into darkness. Instead, it would feel like falling gently, the way a feather drifts toward the ground. The tunnel's curvature guides motion naturally, smoothing the transition from open space into the throat. Your body would feel weightless, supported by the geometry itself rather than by any engine or force. There would be no jolt, no sudden plunge, just a soft sense of being carried forward, as though the universe were lifting you along a curve it carved long before you arrived. The walls of the throat wouldn't be solid. They'd be an abstract shimmer where distance bends and rearranges itself. Everything would feel hushed, suspended, unhurried. To fall into a wormhole is to surrender to a calm path laid out by space-time, a passage that feels less like travel and more like drifting into a dream. And as you move inward, the tunnel begins to stretch into shapes unlike anything in ordinary space. Fact 34. A tunnel that stretches gently inside a wormhole. Distance behaves in ways that feel almost poetic. The tunnel may appear short from the outside, but within, it can stretch into a graceful, elongated corridor where space thins and curves in delicate patterns. It isn't a rigid tube, more like a region where geometry has been encouraged to flow in a particular direction. As you drift through, you might sense the passage unfolding around you, lengthening with each quiet moment, though no physical walls confine you. The tunnel's length is not fixed. It adapts to the curvature of space-time, sometimes stretching, sometimes relaxing, always guiding you toward the far mouth with gentle persistence. It's a reminder that distance inside a wormhole is not something measured strictly in meters, but in how the universe chooses to fold and bend around your path. And as the tunnel stretches, the light within begins to shift into softer hues. Fact 35. Colors that melt and blend light. Traveling through a wormhole would not behave the way it does in open space. As photons follow the tunnel's curves, their paths elongate or compress, causing colors to subtly change. They may stretch into deeper reds or soften into pale blues, blending gently as they glide along warped geometry. To the eye, this could appear as a soft wash of shifting tones, nothing sharp or startling, just a slow, seamless blending of hues, like watercolor pigment dissolving into clear water. These gentle changes aren't illusions. They are the natural response of light to extreme curvature. You might see distant stars rendered in softened colors or faint bands of light drifting like luminous mist. Each color becomes a companion on the journey, transforming with the tunnel's shape. And as the light shifts, the forces inside the tunnel continue their quiet influence, shaping your motion with delicate precision. Fact 36. The whisper of tidal forces. Within any curved region of space-time, tidal forces, the same gentle stretches felt near massive objects, begin to whisper. In a well-formed, stable wormhole, these forces would be mild, spreading evenly across your body so nothing feels pulled or pressed too strongly. The geometry distributes tension like a soft, even breeze, maintaining comfort within the passage. You might feel a faint sense of elongation or compression, so slight it registers more as intuition than sensation, an awareness that space itself is flowing differently around you. These forces guide objects smoothly toward the wormhole's center, aligning their paths so the journey remains quiet and controlled. In this softened environment, gravity becomes not a pull, but a gentle shaping of experience. And as these tidal whispers fade, time itself begins to slip into new rhythms ahead. Fact 37. The sense of time. Slipping. Inside a wormhole, time becomes a quiet companion with unusual habits. It may stretch like warm taffy or shrink into delicate fragments, shifting gently in response to the tunnel's curvature. A journey that feels long and unhurried to you might appear instantaneous to an observer waiting outside, or the reverse may be true. Minutes for them, heartbeats for you. This isn't magic. It's the natural behavior of time under intense but balanced gravity. Within the throat, space-time curves so smoothly that your internal rhythm remains calm, even as the passage warps the clock's steady tick. You might feel suspended in a moment, as though the present has widened to make room for you. Time becomes soft, pliable, and strangely comforting. A reminder that even the seconds can drift when space reshapes itself. And beyond the shifting flow of time awaits a gentle return to the universe's open sky. Fact 38. Exiting into another sky. Emerging from a wormhole would feel like gliding from shadow into light. One moment, you're surrounded by the serene, dim geometry of the throat. The next, the fabric of space unfurls and releases you into a new region of the cosmos. The transition wouldn't be abrupt or jarring. It would feel like stepping through a curtain of warm air into a vast, open world. Above you, a different constellation might shimmer. Stars arranged in patterns your eyes have never traced before. The light might look clearer or richer, shaped by the local physics of this distant region. Even the color of the night sky could shift, depending on where the tunnel leads. There is a quiet beauty in this moment, the feeling of arriving somewhere impossibly far away, yet without having endured the long, lonely journey through normal space. And from this peaceful emergence comes another subtle truth. Your passage leaves almost no mark at all. Fact 39. Traveling without a trace. A wormhole, if stable, allows objects to pass without tearing or disturbing the surrounding space. You slip through the throat like a ripple through water, visible for an instant, then gone without residue. There's no trail of exhaust, no shockwave, no blazing heat left behind. Even the fabric of space-time settles quickly, smoothing itself like silk returning to rest. This near invisibility makes wormhole travel remarkably gentle compared to the energetic demands of ordinary propulsion. The tunnel does the work, shaping your path and carrying you quietly from one mouth to the other. To an outside observer, the only sign of your journey might be a fleeting shimmer of distorted light, a soft echo of your passing. Wormholes allow movement without disturbance, motion without noise. And from this delicate travel comes a deeper understanding. The universe's speed limit remains unbroken. Fact 40. A journey, no faster than light. One of the quiet beauties of wormholes is that they never break the universe's speed limit. You don't outrun light. Instead, the distance between two places is gently folded so the path becomes shorter. It's like stepping across a bridge instead of walking around a long valley. The destination arrives sooner, not because you moved faster, but because the space around you reshaped itself. This means wormholes honor the rules of relativity, preserving the deep harmony of cosmic laws. They offer a shortcut without any rush, a door rather than a race. For the traveler, it feels peaceful, a reminder that reaching a faraway place need not involve force or strain. And from this quiet appreciation of distance, we turn to the wormhole's inner design, beginning with the structure of its throat. Fact 41. The throat and its curvature. At the heart of every wormhole lies the throat, a smoothly curved region where space-time bends in an elegant, continuous arc. It isn't a physical tube with walls or floors, but a zone where distances rearrange themselves, narrowing and then expanding again. If you could trace its shape with your hands, it might feel like gliding along the inside of a gently carved bowl, smooth, seamless, and perfectly balanced. The The throat's geometry determines everything: how light travels, how time flows, and how comfortably an object can pass through. In a stable wormhole, this curvature is gentle, never sharp or sudden. It cradles motion rather than directing it, providing a soft corridor through the warp of space. To travel through the throat is to move within a calm, balanced shape, a passage sculpted by the universe's own equations. And from this central curve, the wormhole expands outward into a broader form. Fact 42. The geometry of comfort. For a wormhole to be traversable, its geometry must protect travelers from extreme tidal forces. This requires the tunnel to curve in a particularly gentle way, spreading gravitational effects evenly so nothing is squeezed or stretched too strongly. It's a passage designed not for speed, but for comfort. A cosmic walkway where the forces of nature have been tuned into harmony. Physicists call this a flare-out shape. The throat widens smoothly toward each mouth, like the opening petals of a flower. This structure ensures that objects drift calmly along the tunnel, unhurried and undisturbed. In essence, the wormhole must be kind, shaped with a softness that allows safe passage. This soothing geometry reminds us that even in the most extreme corners of physics, gentleness has a role. And from these soft curves, the vision of a wormhole becomes even more vivid. Two spheres connected by an elegant seam. Fact 43. Spheres joined by a seam. A simple way to picture a wormhole is to imagine two spherical regions of space, like floating bubbles, connected by a smooth, hidden seam. Each sphere represents one mouth of the wormhole, while the seam between them is the tunnel that links their interiors. From the outside, each mouth appears as a rounded boundary, where space curves inward, a soft distortion shaped by the tunnel beyond. If you could stand beside one mouth and gaze in, you wouldn't see the seam itself. You'd see the distant world on the far side, framed by a perfect circular window. The tunnel remains invisible, tucked within the fabric of space-time like a secret thread inside a carefully woven garment. This simple geometry, two spheres and a graceful connection, captures the elegance of wormholes. And lining that connection is something even more unusual, a delicate film of exotic matter. Fact 44. The thin shell of stability. To hold the wormhole's throat open, physicists propose a thin shell of exotic matter spread lightly along the tunnel's inner surface. This isn't a thick wall or mechanical support. It's more like a faint, negative energy mist that balances the natural urge of the tunnel to collapse. The shell would be incredibly subtle, almost weightless, yet powerful enough to shape the wormhole's stability. It counters gravity's inward pull with an outward push, so gentle it feels like the universe is breathing softly through the tunnel. Without it, the throat would pinch shut instantly, sealing the passage like a collapsing bubble. Though exotic matter remains theoretical, its presence in equations offers hope that wormholes could one day be more than mathematical curiosities, perhaps even cosmic structures with real navigable interiors. And inside these supported corridors, familiar forces take on unfamiliar forms. Fact 45. Magnetic fields. Gone. Strange, magnetic fields, which normally form graceful loops around stars and planets, would behave very differently inside a wormhole. As they enter the tunnel, their lines would stretch and twist through the curved geometry, bending in ways impossible in open space. A field that seems simple near the mouth might break into swirling patterns deeper inside, looping through the throat, like ribbons drawn through swirling water. To a sensitive instrument, these fields might appear fractured or mirrored, their direction shifting as they pass from one mouth to the other. Yet the process would be gentle and smooth, shaped entirely by geometry rather than turbulence. This strange behavior reminds us that even familiar forces become poetic inside a wormhole, bending, spiraling, and drifting in harmony with the tunnel's curves. And just beyond these shifting fields lies one of the wormhole's most surprising possibilities, a passage that mimics gravity without mass. Fact 46. A quiet absence of mass. One of the most surprising things about a wormhole is that it can imitate the gravitational pull of a massive object without actually containing mass. From far away, a wormhole mouth might behave like a star or a dense planet, curving space so that nearby objects drift in graceful arcs around it. But if you measured the matter inside, you'd find none. Only the geometric shape of space-time creating the illusion of mass. This is because gravity and relativity arises from curvature, not from physical substance alone. A wormhole bends the fabric just enough to guide motion, yet leaves nothing at its center that behaves like a traditional object. It is a presence defined by shape, not weight. A quiet reminder that gravity is a story told by geometry. And when light passes near this shapely presence, it reveals the wormhole's silhouette with an elegant shadow. Fact 47. The shadow of the mouth. While a wormhole isn't a solid object, its curved geometry still casts a kind of shadow. As starlight bends around the mouth, some rays are redirected, some stretched, and some blocked from certain angles. This creates a soft, rounded darkness, not the harsh void of a black hole, but a gentle silhouette outlining the circular edge of the tunnel. To an observer, this shadow would look like a calm, dark opening surrounded by a halo of distorted stars. It wouldn't flicker or glow, but it would stand out against the sky, a quiet gateway framed by celestial light. Scientists imagine that, with precise instruments, such silhouettes could one day reveal the presence of wormholes hidden among the stars. And if something small drifted too near this mouth, its behavior would tell an even clearer story. Fact 48. The entry of stray particles. Dust, gas, and wandering particles behave differently near a wormhole than they do around ordinary stars. Instead of spiraling into a fiery furnace or falling onto a solid surface, they drift gently toward the mouth, pulled along the smooth curves of space-time. Some particles slip through the tunnel, emerging on the far side like whispers carried by a silent current. Others skim the edges, tracing soft arcs that reveal the passage's pull. There is no violent heating, no bright accretion disk, just a calm, graceful migration guided by geometry. The wormhole doesn't feed or consume, it simply offers a path, and the lightest fragments of the universe accept the invitation. These drifting particles help paint a picture of a portal that is serene, not dangerous, a doorway that invites rather than devours. And beyond this gentle behavior lies another quiet truth. Such portals may release almost no heat at all. Fact 49. A portal without heat. Wormholes, unlike stars or black holes, give off almost no heat. They have no burning core, no swirling disk of matter, no intense radiation pouring from their mouths. Instead, they sit quietly in the darkness, shaped only by the gentle curvature of space-time. If you drifted near one, you wouldn't feel warmth or cold caused by the portal itself, only the natural temperature of the surrounding cosmos. This calm presence makes a wormhole almost ghost-like, detectable only through the way it bends light and guides motion. The absence of heat also hints at the tunnel's delicate structure. Nothing inside is being torn apart or crushed, and no energy is violently released. It is a passage defined by stillness rather than flame, a doorway carved from pure geometry. And if such a quiet structure ever passed near Earth, we might notice it not by heat, but by subtle distortions in space itself. Fact 50. The signature in spacetime. A wormhole drifting close to Earth wouldn't make noise or cast shadows across the land, but it might leave gentle footprints in the fabric of spacetime. Tiny shifts in gravitational fields that could be measured with sensitive instruments. Clocks might tick at slightly different rates. Lasers might travel along paths that gently curve, and faint ripples might dance through the measurements of observatories looking for gravitational waves. These signs would be incredibly delicate, almost like the brush of a feather against silk. But they would form a recognizable pattern, a localized pocket of curved space, not caused by mass, but by geometry alone. Scientists searching for wormholes imagine detecting such signatures one day, reading the quiet distortions like notes in a cosmic diary. And as researchers refine their instruments, they turn their attention to the skies, looking for the soft lensing effects that might reveal an unseen portal. Fact 51. Searching for subtle lensing. Because wormholes bend light, astronomers often search for them by studying the patterns of distant stars. If a wormhole sits between us and a faraway object, it can split or distort the incoming light, creating doubled images or soft arcs that shouldn't exist in ordinary space. These distortions are gentle, nothing like the dramatic contortions caused by black holes, but they are distinct enough to hint at a tunnel hidden along the line of sight. A wormhole's lensing might last only moments if the objects move relative to one another, appearing as a brief brightening or a sudden clone of a distant star. Observers who catch such events study them carefully, wondering whether they've glimpsed a natural warp in the universe. These fleeting distortions remind us that the cosmos hides its secrets softly, revealing them only to patient, attentive eyes. And beyond these subtle signs lie deeper echoes in space-time itself. Fact 52. Ripples in gravitational waves. When massive objects collide, like black holes or neutron stars, they send ripples through space-time known as gravitational waves. These waves travel across the cosmos, stretching and squeezing space with gentle, rhythmic pulses. If a wormhole existed along their path, it could alter these ripples in subtle, distinctive ways. Instead of passing smoothly through, the waves might echo, refract, or even appear delayed, creating patterns that differ from ordinary gravitational signals. Observatories listening to the universe's quiet tremors could detect these anomalies as faint signatures of a hidden tunnel. This doesn't require the wormhole to vibrate or emit energy. It simply sits there, shaping the passing waves the way a pebble shapes ripples in a stream. And from these gentle cosmic murmurs, astronomers learn to look for even stranger motions in the stars themselves. Fact 53. Stars with impossible motions. Sometimes, stars near the center of galaxies move in ways that challenge expectations. Their orbits twist or accelerate in patterns too unusual to be explained by the visible mass around them. While dark matter is the leading explanation, some scientists speculate that a wormhole could create similar effects, gently pulling or redirecting the motion of nearby stars with its unique geometry. A star influenced by a wormhole might seem to orbit an invisible partner or shift its course without any sign of an intervening object. These motions wouldn't be violent or chaotic. They would be graceful, long looping arcs shaped by the quiet pull of curved spacetime. If such a pattern were confirmed, it could point to a wormhole masquerading as empty space, guiding stellar paths from behind the curtain of reality. And from strange orbits, attention turns to something even more curious: light arriving sooner than expected. Fact 54. Light that arrives too soon. Light usually follows the straightest possible path through the cosmos. But if a wormhole provides a shortcut between two regions, a beam traveling through it could arrive earlier than expected, beating the journey through ordinary space. Astronomers studying distant flashes or bursts of energy might one day detect such anomalies. A signal that seems to take the long route, paired with another that inexplicably arrives early. This early arrival wouldn't be faster than light travel. It would simply be the result of a shorter path, like taking a hidden corridor while everyone else walks around the building. The difference would be tiny, but measurable. A whisper of geometry revealing itself in the timing of photons. Such signals would be precious clues, hinting that space holds more connections than we can see. And from these early arriving rays, we drift next toward high-energy bursts that carry quiet secrets of their own. Fact 55. Gamma rays with soft secrets. Gamma rays are among the most energetic forms of light, born in distant explosions and cosmic collisions. Normally, they travel in straight, unwavering lines across the universe. But if a wormhole sits along their path, those rays could scatter, echo, or emerge from an unexpected direction, almost like reflections off a surface that isn't really there. These patterns might appear as faint duplicates of a burst, or as gentle afterglows that don't match the timing of the original event. To astronomers, such mismatches could be quiet hints of light passing near, or even through, a hidden tunnel. Nothing about the effect would be violent. It would feel more like listening to an echo across a canyon, soft, delayed, and intriguing. And from these subtle high-energy clues comes the possibility that even entire distant galaxies might appear doubled. Fact 56. Quasars shining twice. Quasars, brilliant ancient beacons powered by supermassive black holes, shine across billions of light years. In rare cases, telescopes have spotted quasars appearing twice in the sky, their images separated by small angles as though seen through a cosmic mirror. While gravitational lensing from galaxies explains most of these duplicates, some scientists wonder if a wormhole could mimic the effect. A wormhole's curved geometry might allow light from a single quasar to arrive along two paths, one traveling through normal space, the other slipping through the tunnel. The result would be two serene images of the same object, glowing softly in different locations with subtly mismatched timings. To the patient observer, it would seem as though the universe gently repeated itself, offering two windows onto the same distant light. And these doubled glimpses lead naturally to even briefer, more delicate signs, tiny brightenings lasting only moments. Fact 57. Microlensing whispers. Sometimes, the brightness of a distant star increases for just a short time, as though something unseen passed briefly between us and the star. This phenomenon, called microlensing, is usually caused by a small object, perhaps a planet or compact mass, bending the light through gravity. But a tiny wormhole could create a similar effect, brightening the star with a signature all its own. The brightening would be gentle and transient, a soft swell of light rather than a flare. It might last hours or days, leaving behind only a small distortion in the star's apparent position. Such an event would be difficult to distinguish from ordinary microlensing, but careful study could reveal the subtle imprint of a wormhole's unique geometry. These fleeting glimmers remind us that the universe often speaks in whispers, offering momentary clues hidden in the dance of starlight. And from these whispers, attention turns to the mysterious mass that fills the cosmos in shadow. Fact 58. Dark matter's hidden clues. Dark matter, that quiet, invisible substance shaping galaxies from behind the scenes, may conceal more than just mass. Some theories suggest that small, dormant wormholes could be entwined within these shadowy halos of gravitational influence. Because dark matter does not emit or absorb light, anything hidden inside it, including collapsed or silent wormholes, would remain unseen. If wormholes drift within these invisible structures, their effects would blend with the gravitational shaping already attributed to dark matter. The subtle pull, the odd arrangement of stellar orbits, the unseen weight, they could conceal tunnels curled deep inside the cosmic fog. We cannot yet distinguish dark matter from wormhole geometry, but the possibility warms the imagination that hidden passages may drift quietly among the galaxies, wrapped in the soft cloak of the universe's invisible mass. And from this quiet speculation, we turn to even fainter whispers in the glow of the cosmos's earliest light. Fact 59. Patterns in cosmic background. Noise. The cosmic microwave background, a gentle afterglow from the birth of the universe, is filled with tiny temperature variations, soft mottled patterns that record ancient ripples in space-time. If primordial wormholes once dotted the early cosmos, they may have left faint fingerprints in this ancient light. These imprints would not look like sharp marks or obvious shapes. Instead, they might appear as small anomalies, unusual symmetries, or tiny regions where the background's smooth randomness subtly deviates. Detecting such patterns would require immense precision, listening closely to the hum of the universe's oldest memory. Though no confirmed signs exist, scientists continue to study this quiet radiation, knowing it could carry echoes of tunnels formed when the cosmos was young. And as we search the sky for these delicate clues, we develop instruments that listen ever more sensitively to the universe's faint messages. Fact 60. Listening for the universe's footsteps. Modern observatories do more than look. They listen. They tune themselves to the gentle vibrations of space-time, the faint trembling of distant collisions, and the soft distortions caused by passing masses. In this cosmic listening, scientists hope to hear the subtle signature of a wormhole, a slight delay in a ripple, a faint echo, or a distortion that cannot be explained by ordinary matter. These instruments must be incredibly sensitive, able to detect changes smaller than a fraction of a proton's width. Yet they continue to improve, stretching humanity's hearing deeper into the universe. If a wormhole ever drifts near, it may leave a quiet imprint in these recordings, a soft footstep on the cosmic floor. This listening marks the threshold between detection and imagination, inviting us toward possibilities that lie far beyond our current reach. And from this patient search, our thoughts drift toward how these portals might one day be used. Fact 61. A shortcut for exploration. If wormholes could be stabilized, even for brief periods, they would become the most graceful shortcuts ever imagined. Instead of spending centuries drifting between stars, explorers might step gently through a tunnel and emerge light years away in a single serene moment. No roaring engines, no harsh acceleration, just a calm passage through a fold in space-time. This kind of travel wouldn't feel like conquering distance. It would feel like accepting an invitation, a quiet walk through a doorway that nature already shaped. Whole regions of the galaxy that once seemed unreachable could come within effortless reach, transforming exploration into something peaceful and accessible. Such shortcuts would open the universe like a vast garden, letting travelers wander from star to star with the simplicity of stepping across a threshold. And from this idea of travel comes the notion of communication, messages slipping through these portals with equal ease. Fact 62. Portals for interstellar communication. Even if wormholes could never carry spacecraft, they might still allow messages to pass through. A stable tunnel could let information jump across light years in an instant, linking distant civilizations or far-flung research stations with calm, quiet efficiency. Imagine sending a greeting to a world thousands of light years away and receiving a reply moments later, not through speed, but through geometry. The signals would travel gently, guided by the curvature of the throat rather than by powerful transmitters. It would be communication shaped by silence, carried by the folds of the universe. Such channels could allow scientists separated by entire galaxies to share discoveries as easily as neighbors exchanging notes across a fence. In this vision, wormholes become cosmic bridges of understanding, not just pathways for travelers. And if enough of these bridges existed, a new kind of cosmic infrastructure might take shape across the stars. Fact 63. A network of cosmic pathways. Imagine a galaxy threaded with stable wormholes, each connecting distant regions like a web of quiet passageways. Travelers could drift from one portal to the next, hopping across thousands of light years with minimal effort. Trade, exploration, and scientific study would unfold across this network, turning the Milky Way into a gently connected community of worlds. These pathways wouldn't disrupt the natural beauty of space. They would simply rest within it, like soft threads woven through an immense tapestry. The network could expand slowly, each new tunnel opening a fresh chapter of discovery. Over time, the galaxy might feel smaller, not in a limiting way, but in a comforting one, a place where distances no longer isolate, but softly connect. Such a web of wormholes would change not just how we travel, but how we imagine our place in the cosmos. And from these woven paths comes a more personal thought. What might such portals mean for generations yet to come? Fact 64. A bridge to future generations. Wormholes, if ever stabilized, could become gentle connections not just across space, but across time itself. A tunnel whose mouths experience different gravitational environments might create a slight offset in the passage of time. This means descendants in the distant future could, in theory, meet travelers from the present, not through paradox or time machines, but through the natural flow of relativity. Such a bridge would be subtle, not dramatic. The effect might be faint, a few years gained or lost, depending on how long each mouth has been exposed to different conditions. But even this small shift paints a beautiful idea that wormholes could link generations separated by the slow unfolding of cosmic history. It is a tender vision. Families of explorers leaving notes across centuries, sharing wisdom through a doorway carved by geometry. And as we dream of these links across eras, we can imagine wormholes serving as windows into distant realms. Fact 65. Windows into distant galaxies. A wormhole does not always need to be a tunnel for travel. It can also serve as a window, a stable opening that reveals a faraway region of of the universe. Through such a mouth, astronomers could study galaxies too distant to reach with any telescope. Light from billions of light years away might pass directly through the tunnel, arriving with clarity and brightness impossible to achieve through ordinary observation. Imagine looking up at the sky and seeing, framed in the round mouth of a wormhole, a swirling galaxy glowing with newborn stars. It would feel like peering through a cosmic lantern, a gentle, natural observatory connecting two corners of the cosmos. Such windows would transform our understanding of the universe, offering quiet glimpses into places otherwise hidden by distance. And if scientists and explorers visited these portals often, they might one day build vessels designed to live beside them. Fact 66. A new kind of science vessel. If wormholes became stable enough to study closely, humanity might construct special vessels meant to linger near their mouths, not to force passage, but to observe, measure, and learn. These ships would be calm outposts in space, floating stations where researchers could monitor the throat's geometry and listen to the whispers of passing particles. Such vessels wouldn't need powerful engines or heavy shielding. Instead, they would rely on precision instruments, gentle propulsion, and long-term stability. Life aboard would be peaceful, dedicated to watching the ebb and flow of space-time. Over years or decades, these ships could map the wormhole's subtle changes, tracing how the tunnel breathes with the universe's shifting tides. They would be caretakers of cosmic doorways, guardians of fragile connections. And from these vessels of study, imagination drifts naturally toward the possibility that wormholes might one day touch the edges of time itself. Fact 67. Time travel without paradox. Wormholes have long been whispered about as possible gateways through time, not in the dramatic, jarring way of fiction, but in a quiet, natural manner shaped by gravity itself. If one mouth of a wormhole were moved near a strong gravitational field or accelerated to high speed, time would pass more slowly for it than for the stationary mouth. When the two mouths reunite, they would no longer share the same now. Passing through such a wormhole could lead a traveler slightly into the future or the past relative to someone standing outside. There would be no explosions of chronology, no unraveling of reality, just a gentle slip between moments crafted by the universe's own rules. This kind of time travel avoids paradox because the wormhole's geometry keeps events consistent, its timeline woven into a single, self-contained loop. And from this soft bending of time, imagination flows toward meeting lives far removed from our own. Fact 68. Meeting our far-off descendants. If wormholes could shift time subtly, they might allow distant generations to meet, not through fantasy, but through the steady workings of relativity. Imagine a traveler who steps through a wormhole to find that decades or centuries have passed on the other side. There, waiting in the glow of a different era, could be the descendants of those who first opened the tunnel. The meeting wouldn't be dramatic or disorienting. It would feel like stepping into a quieter, gentler continuation of one's own story. The travelers might share tales of early exploration while the future listens with wonder, seeing living echoes of ancestors they once studied only in history. Such encounters would deepen our sense of connection through time, showing that knowledge and curiosity outlive every generation. And beyond these human dreams lies the possibility of entire environments adapting to the presence of such portals. Fact 69. The ecology of two skies. If a stable wormhole rested near a planet for long enough, ecosystems might quietly adjust to its presence. Light from a distant region of the universe could spill through the mouth, creating unusual patterns in the sky. A faint, circular glow showing stars no local creature had ever evolved to see. Animals might become attuned to this extra landmark, using it for navigation the way birds follow the moon. Plants could respond to the gentle trickle of new wavelengths, growing subtly, different leaves or flowers beneath the wormhole's soft illumination. Even the climate might shift slightly if the portal allowed small amounts of energy to pass through. This ecology of two skies paints a serene picture of life adapting not to chaos, but to an added window on the universe, a reminder that nature is endlessly resourceful. And from these living adaptations, we drift naturally to a grander vision, a universe connected like a vast, thinking web. Fact 70. A universe connected like neurons. If wormholes dotted the cosmos, even sparsely, even quietly, the universe might begin to resemble a vast, interconnected network. Each wormhole would act like a node, linking distant regions the way neurons connect through delicate filaments. Information, matter, or light could travel through these pathways, giving the cosmos a kind of structural harmony, as though it were thinking softly through its own geometry. This doesn't imply intelligence in the conscious sense, but a natural elegance, a system where remote places communicate through hidden threads. In this view, wormholes become the junctions of a cosmic mind, the subtle connectors that turn scattered regions into a unified whole. It's a peaceful image, a universe not defined by emptiness and separation, but by quiet bridges woven through its deepest fabric. And from this vision of structure, we drift into the realm of stories, the myths that long preceded any equations. Fact 71. Ancient myths of hidden pathways. Long before physics offered equations, human imagination whispered about secret routes between worlds. Many ancient cultures spoke of enchanted paths, sky bridges, or spirit tunnels where travelers could step from one realm to another without crossing the lands between. These stories carried a soft echo of the wormhole idea, that distance can fold, that realms can touch, that the world holds quiet shortcuts only the brave or blessed can find. Though these myths were not scientific, they reflected a universal longing, the desire to reach the unreachable, to slip through the seams of reality and find what lies beyond. The tales often describe the journey not as chaotic or frightening, but as gentle, mystical, and transformative. These ancient whispers foreshadow the modern fascination with cosmic portals. And from these early stories, we move to the folklore that imagined doorways with even greater intimacy. Fact 72. Doorways and folklore. Throughout folklore, there are countless tales of hidden doors, stone arches in forests, shimmering thresholds at dusk, and secret passages between mountains that appear only at certain moments. These doorways often lead to distant lands or dreamlike realms where time flows differently, and the sky glows with unfamiliar stars. Though created in a world without astrophysics, these stories feel surprisingly close to the idea of wormholes. They speak of transition without travel, of emerging somewhere new without crossing the intervening space. The experience is always portrayed as gentle, stepping through a doorway and finding oneself under a different sun, a different moon, or a different season. These folklore doorways echo the poetic possibility that the universe, too, may hold its own hidden thresholds. And from this timeless storytelling, we glide toward the imagination of early science fiction, where wormholes first gained their modern name. Fact 73. Portals in early science fiction. Long before wormholes had formal equations to describe them, early science fiction writers imagined doorways through space with remarkable intuition. They described tunnels cut through the stars, shortcuts between distant worlds, and shimmering passages woven by mysterious forces. These stories emerged in an era when even the structure of galaxies was still being puzzled out. Yet the human imagination instinctively reached for the idea of folding distance. The authors portrayed these portals not as violent ruptures, but as elegant doorways, gentle, glowing thresholds that invited explorers into the unknown. Their visions often aligned uncannily with what modern physics would later propose. Smooth tunnels, round openings, and transitions that felt almost effortless. These early creations helped shape how we picture wormholes today, giving scientific ideas a narrative home long before the math was written. And from these speculative tales, we drift toward the broader theme they all share: the dream of bridges between worlds. Fact 74. Bridges between worlds. Across literature, myth, and modern science, the idea of a bridge connecting faraway realms appears again and again. Sometimes it's a rainbow arc linking heavens and earth, sometimes a misty path through mountains, and sometimes a shimmering portal suspended among the stars. Wormholes fit naturally into this lineage, scientific bridges that echo ancient metaphors. These connections reveal something deep in the human spirit, a quiet desire to bring distant places closer, to soften the vastness of existence. Whether the bridge is imagined or theoretical, it represents possibility, the chance to step from the familiar into the wondrous without facing an impossible journey. In this way, wormholes aren't just mathematical constructs, they're expressions of a timeless longing that faraway lands, distant stars, and unknown worlds might be reachable through a gentle passage. And from this universal desire, our cultural storytelling evolves into the modern age, where wormholes become symbols of exploration and hope. Fact 75. Wormholes in modern stories. In contemporary books and films, wormholes often appear as graceful cosmic gateways, swirling with soft light, humming with quiet energy, or shining like halos against the darkness. Though dramatized, many of these depictions preserve the essence of the scientific idea: a smooth tunnel, a curved path, a doorway shaped by the bending of space-time. Modern stories use wormholes not only as plot devices, but as symbols. They represent connection, the bridging of impossibility, the linking of distant hearts or distant planets. Characters step through them to find new worlds, new eras, or even new versions of themselves. These portrayals remind us that the idea of a wormhole touches both our curiosity and our emotions. They show that even the most advanced scientific concepts can carry a sense of warmth, a promise of discovery softened by wonder. And from these cultural reflections, we drift toward deeper symbolism, where wormholes stand for inner journeys as much as cosmic ones. Fact 76. Beyond the plot device. Wormholes in stories often begin as tools for travel, convenient shortcuts for characters to reach distant places. But gradually, storytellers have embraced them as more than mechanisms. A wormhole can symbolize transition, transformation, and the quiet courage required to cross from one chapter of life into another. These fictional passages often mirror emotional journeys, stepping through uncertainty, trusting in the unknown, emerging changed on the other side. They remind us that growth often feels like crossing an invisible threshold, a moment where we leave behind the familiar and open ourselves to something new. In this way, wormholes in fiction become metaphors for renewal, healing, and possibility. They teach us that even the most mysterious paths can lead to places of clarity and peace. And from these symbolic bridges, we move to deeper reflections on why humans dream of such doorways at all. Fact 77. The human longing for elsewhere. Across cultures and generations, people have felt a soft pull toward the beyond, a yearning for places just out of reach. This longing isn't escape, it's curiosity, woven into the quiet corners of the human spirit. Wormholes, as imagined or theorized, give shape to this longing. They offer the idea that somewhere, beyond the horizon of our understanding, there may be gentle paths leading to new landscapes. This desire for elsewhere can be emotional as much as physical. It might whisper in moments of reflection, in dreams of distant stars, or in the wish to understand ourselves more deeply. Wormholes become symbols of our hope that the universe is open, not closed, connected, not isolated. They reassure us that even the vastest distances might hold a welcoming thread. And from this longing for distant skies, we turn inward, toward wormholes of the mind and heart. Fact 78. Portals to inner worlds. Wormholes often inspire metaphors about exploring the self. Just as a wormhole bends space to reveal hidden regions of the cosmos, introspection bends awareness to reveal hidden regions of our inner landscape. In quiet moments, especially those before sleep, our thoughts drift like travelers through a tunnel, moving from memory to imagination, from reflection to insight. These inner pathways feel soft, intimate, and fluid, much like the smooth curves of a cosmic tunnel. They allow us to connect distant experiences, linking moments in our lives that once felt far apart. Through these mental wormholes, we gain new perspectives, blending past and present into calm understanding. In this gentle way, the metaphor of a wormhole becomes personal, a reminder that the universe's deepest mysteries echo within us. And from this inner reflection, we drift toward the comforting idea that wonder itself can be a source of peace. Fact 79. The comfort of vast ideas. There is a quiet peace that comes from contemplating something larger than ourselves. Wormholes, with all their mystery and gentle impossibility, offer that comfort. They remind us that the universe is spacious enough to hold wonders we haven't yet touched, and generous enough to leave room for possibility. Thinking about these cosmic doorways can soften the mind, widening our sense of perspective the way a horizon widens a traveler's view. Vast ideas don't overwhelm when approached calmly. They soothe us, replacing daily concerns with a sense of quiet scale. Wormholes become part of this calming landscape, reminders that the cosmos is full of gentle surprises, each one a soft invitation to dream. And from this comforting vastness, we drift into deeper philosophical waters, asking what wormholes suggest about the universe's deeper architecture. Fact 80. The language of wonder. Wormholes exist at the intersection of science and imagination, where equations meet poetic curiosity. When we describe them, our words naturally become softer, slower, more metaphorical, as though ordinary language strains to match the elegance of curved space-time. This blend of knowledge and wonder creates a unique vocabulary: mouths and throats, bridges and tunnels, threads and folds. These phrases aren't just technical descriptions. They are part of a gentle storytelling tradition. They help us relate to the cosmos in human terms, making the unimaginable feel intimate and close. Through this language, wormholes become more than mathematical oddities. They become symbols of connection, opportunity, and quiet mystery. In speaking of them, we practice the art of wonder itself. And with this poetic vocabulary in mind, we step into deeper speculation. Are wormholes born naturally, or do they require a guiding hand? Fact 81. Are wormholes natural or nurtured? The question of whether wormholes occur naturally or require the intervention of advanced intelligence has long intrigued physicists. On one hand, the early universe could have produced tiny, fleeting tunnels through its chaotic fluctuations. On the other hand, stabilizing a wormhole into something traversable seems to demand precise control over exotic energies, something far beyond our current abilities. If wormholes do exist, they might be rare gifts of cosmic evolution, drifting quietly between stars, or they might be carefully shaped structures, nurtured by civilizations far older than our own, crafted with patience and understanding. Both possibilities feel gentle, not alarming. The universe either crafting doorways on its own, or intelligent life lending a soft hand to guide geometry into new forms. This question sits at the edge of science and philosophy, shimmering like a distant star. And from this reflection, we move toward the gentle ethics such connections might demand. Fact 82. The ethics of cosmic passage. If wormholes were ever discovered or built, their existence would invite delicate ethical questions. Who decides where a tunnel opens? Who may travel through it, and for what purpose? These doorways would be powerful connectors, not just of places, but of cultures, ecosystems, and histories. Managing them would require care, the same gentle mindfulness one uses when opening a gate between two quiet gardens. The ethics of wormholes wouldn't revolve around danger or conflict. Instead, they would focus on stewardship, ensuring that the worlds linked by such portals benefit mutually, that no environment is overwhelmed, and that fragile life on either side remains protected. This reflection reminds us that even cosmic technologies require compassion. And from these considerations arises another soft caution, the fine line between curiosity and overreach. Fact 83. The quiet dangers of curiosity. Curiosity is one of humanity's most beautiful qualities, guiding us toward discovery with gentle persistence. But even in the peaceful contemplation of wormholes, there is a reminder to proceed thoughtfully. The universe is intricate, and its structures can be delicate. Pushing too eagerly into unknown realms might disturb balances we do not yet understand. This quiet danger isn't dramatic or fearful. It's the same kind of caution one feels when walking across a frozen pond or approaching a wild animal with respect. Wormholes, if they exist, may be stable or fragile, natural or nurtured. Approaching them with care preserves their mystery and honors the cosmic forces that shape them. Curiosity becomes safer when paired with patience, humility, and deep listening. And this gentle caution leads naturally to the idea that even stable wormholes might shift over time. Fact 84. The fragility of tunnels. Through time, wormholes, in theory, can drift, stretch, and even close as the universe around them changes. Gravity, cosmic expansion, and local disturbances can all tug at their geometry, nudging their mouths across space or altering the flow of time between them. Even the most stable tunnel might shift its alignment ever so slightly, like a ribbon floating in a soft breeze. This fragility doesn't make wormholes unusable. It simply means they would be dynamic, living structures of space-time, always adjusting to the rhythms of the cosmos. Travelers and observers would need to anticipate these subtle changes, maintaining watchful calm as the tunnel breathes with the universe. The idea of shifting portals adds a comforting truth. Even cosmic pathways follow the gentle ebb and flow of nature. And from this delicate motion, we drift toward the deeper philosophical thought that distance itself may be an illusion. Fact 85. Distance as an illusion. The idea of a wormhole invites a quiet reconsideration of distance itself. We often imagine space as a vast, unchanging stretch, a silent ocean separating stars and galaxies by unfathomable lengths. But wormholes remind us that this separation might be softer than it appears. If space can fold, if two distant points can touch through curvature, then distance becomes less a barrier and more a flexible concept. In this sense, the universe behaves less like an endless plane and more like a gentle fabric, capable of gathering itself into new shapes. What seems impossibly far may be just a clever folding away from becoming close. Wormholes whisper that distance is not absolute. It is a relationship shaped by the universe's geometry, as fluid and graceful as a drifting ribbon. And from this softened sense of distance, we begin to see the universe itself as a grand narrative, stitched together by hidden connections. Fact 86. The universe as a storybook. When we explore wormholes, it's easy to feel as though we are turning the pages of a cosmic storybook. Each curve of space-time becomes a sentence, each tunnel a chapter, each connection a quiet revelation. In this metaphor, the universe is not a cold mechanical structure, but a beautifully composed tale, one where every region, every star, and every hidden pathway contributes to a larger narrative. Wormholes add depth to this story, offering transitions not unlike the page turns of a novel. They allow the plot of the cosmos to move in unexpected directions, linking distant settings through smooth, elegant transitions. To contemplate them is to feel that the universe is more than a collection of objects. It is a story unfolding across time and space, told in the language of gravity and geometry. And within this story, we find ourselves wondering about the nature of identity when two places touch through a single tunnel. Fact 87. Identity in two places. A wormhole raises gentle philosophical questions about presence. If one mouth lies near Earth and the other rests light years away, what does it mean for a single tunnel to exist in two places at once? It is a single entity stretched across the cosmos, yet it offers two entrances, two environments, two skies. This dual presence suggests that location is not always a solitary truth. Something can belong to here and there simultaneously, held together by a shared geometry rather than by physical continuity. In this way, a wormhole becomes a symbol of connection, of how one thing can touch two worlds without losing its unity. It's a comforting thought that the universe allows for gentle contradictions, for identities that span distances, for structures that unify what seems separate. And from this reflection, we glide into an even softer idea, the peace that comes from accepting the unknown. Fact 88. The peace in not knowing wormholes invite us to wander into realms where certainty gently dissolves. Much about them remains theoretical, resting in the space between mathematics and imagination. Yet there is a soothing peace in this uncertainty, a reminder that not every mystery needs an immediate answer. Some wonders are meant to be contemplated slowly, like distant constellations shimmering at the edge of sight. The universe carries countless questions we cannot fully unravel, and wormholes are among the most delicate. By accepting their mystery, we allow our minds to rest in possibility rather than pressure. We release ourselves from the need for finality and let curiosity stretch us softly into wider perspectives. In this peaceful unknowing, the cosmos feels more welcoming, more open, more filled with gentle invitations. And from this calm acceptance, we drift toward the soft beauty of possibility itself. Fact 89. The beauty of possibility. Wormholes may or may not exist in the way we imagine, yet the possibility alone brings comfort. It shows that the universe is flexible, creative, and generous in its architecture. The equations that hint at wormholes speak of openness, of pathways not yet discovered, of shortcuts through both space and thought. There is a quiet joy in knowing that reality may hold such elegance. Possibility expands our imagination and soothes our worries, reminding us that the cosmos is far from finished in its surprises. Even if wormholes remain forever theoretical, the idea of them enriches our sense of wonder, giving us room to dream beyond the familiar boundaries of distance. They are beautiful, not because they are proven, but because they remind us that the universe might be even more magical than we expect. And with this appreciation of possibility, we envision a universe abundant with unseen connections. Fact 90. A cosmos filled with soft doorways. Imagine a universe where tiny, silent portals drift unseen. Not dramatic gateways, but gentle seams in space-time, resting unnoticed among the stars. These soft doorways might flicker open for moments, or lie dormant for eons, part of the quiet architecture of reality. Even if rarely stable, their presence would suggest that the universe is threaded with hidden relationships, subtle ties between regions that were never truly separate. This vision doesn't rely on spectacle. It paints the cosmos as an interconnected whole, gently stitched together with delicate threads. The idea of countless unseen doorways brings comfort. We are held within a universe that is not empty, but rich with potential paths and peaceful bridges. And from this tapestry of soft connections, we drift toward the final reflections, the closing wonders of wormholes and the quiet depths of space-time itself. Fact 91. The portal within the atom. When we look deeply into matter, far beyond molecules, beyond atoms, beyond even the smallest particles, we find a realm where space-time itself quietly trembles. In this quantum world, distances blur and positions flicker, creating a landscape far more fluid than our everyday experience suggests. Some physicists imagine that tiny wormholes could exist within this shimmering quantum foam, opening and closing on scales so small they could never be seen directly. These microscopic tunnels wouldn't allow travel or carry messages. Instead, they would simply be part of the natural restlessness of the vacuum, tiny wrinkles forming and smoothing out in the fabric of space. Their presence, if real, would hint that wormhole-like structures are woven into the universe at every level, from the grand arcs of galaxies to the smallest quivers of reality. And from this atomic dance, we're reminded that connections may exist at every scale, linking moments as softly as they link places. Fact 92. A bridge. Between every moment, wormholes are often imagined as spatial shortcuts, but they also inspire reflections on time itself. Just as two distant points in space can be connected through a fold, so too can distant moments in our lives be joined by memory, meaning, and experience. A thought from childhood may surface in the quiet of night, as vivid as if no years had passed. A dream from long ago may feel suddenly present, as though time has curved gently inward. This isn't time travel in the scientific sense, but a reminder that our inner world contains its own soft wormholes, emotional and mental pathways that link who we were with who we are. These connections help us understand our own story, bridging moments across the years with tenderness and insight. In this way, wormholes become metaphors for the temporal threads that tie our lives together. And from these personal bridges, we step out again into the vast architecture of the cosmos. Fact 93: the universe's secret architecture. The more we learn about space-time, the more it reveals itself as a masterpiece of quiet complexity. Its structure is not random, but delicately organized, filled with curves, ripples, and patterns shaped by gravity, energy, and the hidden rules of physics. Wormholes, whether rare or common, stable or fleeting, fit naturally into this architecture, elegant expressions of the universe's ability to bend, connect, and reshape itself. Their existence would mean that reality is not strictly linear, not strictly separated, but gently interconnected. Even if wormholes remain purely theoretical, the equations that predict them reflect a deeper truth. The cosmos is more intricate, more flexible, and more beautifully constructed than we can easily imagine. Contemplating this architecture invites us to breathe slower, to feel held within a universe that shapes pathways with quiet intention. And with that sense of cosmic craftsmanship, we drift toward the final reflections on the softness of warped space itself. Fact 94: the gentle strength of curvature. Curvature is the quiet sculptor of the universe. It bends space without force, guides motion without touch, and shapes entire galaxies through the soft persistence of gravity. A wormhole, at its heart, is simply curvature arranged in a special way, a gentle tightening and opening of the cosmic fabric, forming a passage where distance folds like cloth. This bending isn't violent or abrupt. It's more like the slow arc of a branch under falling snow, or the soft dip of a hammock settling under its own weight. The universe curves smoothly, patiently, creating structures that are both strong and delicate. Wormholes represent the most poetic expression of this strength. A doorway formed not by tearing space, but by inviting it into a new shape. This gentle strength reminds us that even the grandest cosmic forces can be subtle. And from this softness in geometry, we start to see how the universe arranges its distances into quiet harmony. Fact 95: the harmony of distances. Distances in the cosmos can seem intimidating. Light years stretching into unfathomable scales, galaxies glowing far beyond reach. Yet when we think about wormholes, these distances begin to feel less like barriers and more like notes in a cosmic symphony. Each stretch of space, each gap between stars, contributes to the rhythm of the universe, creating patterns that guide the motion of planets, the dance of galaxies, and the slow bloom of cosmic evolution. Wormholes suggest that even these vast separations may be part of a deeper harmony, one where the universe occasionally folds itself into surprising connections. They remind us that distance is not loneliness, it is structure. And that structure, no matter how wide, carries its own quiet beauty. In the soft interplay of separation and connection, the cosmos reveals its deepest calm. And from this harmonic stillness, every movement we make becomes a quiet echo across space-time. Fact 96: the echo of every step. Every action we take, Every breath, every movement creates a ripple in space-time. These ripples are tiny, far too small to detect, but they are real, subtle adjustments in the curvature around us, like the faintest tremor spreading across a tranquil pond. On cosmic scales, celestial bodies create larger echoes, shaping the geometry of the universe with their mass and motion. Wormholes extend this idea further. If one existed nearby, even a small movement through its mouth would send gentle vibrations along the tunnel, echoes carried through its curved interior. These shifts wouldn't be disruptive. They would be soft, harmonic responses, the universe acknowledging passage. It's comforting to imagine that space-time listens quietly, responding with tenderness to every step taken within it, whether across a planet's surface or through a cosmic bridge. And from this delicate echo, we move toward the wormhole's final invitation, the silent call toward discovery. Fact 97. The silent invitation. Wormholes, whether real or imagined, feel like invitations whispered by the cosmos. They do not shout their presence or demand attention. Instead, they offer a quiet possibility that the universe may hold hidden paths for those who seek them with patience and wonder. Their existence suggests that reality might be more generous than it appears, capable of folding itself softly to bring distant places closer. This invitation is not urgent. It is timeless, waiting in the quiet spaces between stars and in the calm corners of our imagination. When we contemplate wormholes, we are reminded that curiosity itself is a kind of journey, one that leads us gently into deeper understanding without requiring us to rush. A wormhole, real or not, represents openness, a serene doorway to the unknown. And from this invitation arises one of the most delicate ideas of all, the possibility of meeting another version of ourselves. Fact 98. The possibility of meeting ourselves. If wormholes can connect different regions of space and time, they stir a philosophical question that feels both tender and profound. Could we, in some distant scenario, encounter another version of ourselves? Not in a dramatic or impossible sense, but as a natural consequence of space-time looping softly into itself. Such a meeting would not be filled with paradoxical upheaval. It would be gentle, like recognizing a familiar melody played on a different instrument. This other you would be shaped by different choices, different environments, perhaps even a different era. Yet beneath all those differences lies the same spark of curiosity, the same quiet longing that gazes up at the stars. Imagining this meeting encourages compassion. It reminds us that every version of ourselves, past and future, seeks understanding and calm. And from this tender reflection, we approach the final idea, a doorway we have not yet found, but quietly hope for. Fact 99. The door we haven't found. Yet somewhere in the vastness of the cosmos, a wormhole might exist right now, stable, silent, and waiting. It could drift in an unseen corner of interstellar space, or rest near a dim, quiet star, hidden by distance or gentle distortions too subtle for our instruments. We have not yet found such a doorway, but the universe is spacious, and its secrets reveal themselves slowly. The idea of this unseen portal offers comfort. It means discovery is still ahead of us, that even with all we've learned, there remain threads of wonder waiting to be touched. The door we haven't found symbolizes curiosity unfurling into the future, guiding exploration with soft hope rather than urgency. It stands as a gentle reminder that the universe will always hold surprises, patiently waiting for the moment we're ready to see them. And beyond that unseen door lies the final reflection, the quiet, endless sleep of space-time itself. Fact 100. The endless sleep of space-time. In the deepest stillness of the cosmos, space-time rests like a vast, quiet ocean. Its curves settle into gentle tides, its ripples fade into silence, and its hidden passages, wormholes or otherwise, drift peacefully within the dark. Whether they exist as stable tunnels or only as fleeting possibilities, they remind us that the universe holds its secrets with patience, never rushed, never hurried. In this endless calm, wormholes become symbols of the universe's dreaming nature, soft folds of possibility in a fabric that stretches beyond understanding. As we imagine them, we drift with the cosmos itself, rocked by the quiet rhythm of gravity and time. And in that rhythm, we find a place to rest, held by the sleeping universe, without fear or urgency. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. Wormholes may remain mysterious, but their soft possibilities remind us that the universe is full of quiet beauty, patient, inviting, and endlessly connected in ways we're only beginning to imagine. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions help guide future journeys, shaping new pathways through science and serenity. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.